Okay, this is 6-3, which continues from yesterday. If you found the last lesson a little overwhelming, no worries, because this kind of tags right onto it, and hopefully will clear up some of the difficulties that you might have had. This one's on exponential growth and decay. The notes are easiest if you've had access to a printer and were able to print them. If not, it's okay. You just might need to pause the video a little more frequently to keep up with me. Okay, so the exponential growth or decay function we already looked at yesterday. It is f of x equals a times b to the x. X is typically a length of time, years or hours or something like that. The a is going to be your starting point. We call it your initial value. And your b is your growth or decay factor. Growth if it goes up, decay if it goes down. Now, the ones we did yesterday, you had that value. Today, sometimes you have it and sometimes you have to find it. If you have a growth, something increases. You start off with all of something, 100%, which is just 1, and you increase or add by a certain percentage. If you have a decay, you start with all 100% or 1, and you decrease by the percentage. Now remember how to turn a percentage into a decimal. That's what you'll need to do here. All right, let's get started. Number 1 and number 2 go ahead and give you the growth factor. So in these, they're giving you that b. They're also giving you the initial value, or the a. So to write the function, f of x equals the a, the initial value, times the growth factor, 1.3, to the x power. The variable will always be the exponent. All right, go ahead and try number 2. Pause the video if you need to. All right, did you get f of x equals 100 and then 0.3 to the x power? You'll notice that a growth is always going to be a 1 point something because it's added to the 100%, where the decay will always be less than 100%. All right, number 3 and 4, they did not give you the growth or decay factor. They did give you the initial value though, and they gave you a rate of increase, which is a growth, or decrease, which is a decay. Remember what I said, you start off with the 100% and you add in the growth. But that's a 1 and that's a 0.05. So we're going to use a 1.05 as our growth factor. See if you can write the function. Did you get f of x equals 100 times 1.05 to the x power? All right, number 4 is a decrease. So in this case, you're 100% less the 40%, which would be a 1 less a 0.40 or a 0.4. In other words, a 0.6 decay factor. Your function, initial value, multiplied by the decay factor to the power. Okay, that's all well and good. Now let's actually use it in a situation. Number 5, you have a little town called Hillville with a population of 5,000 and an annual growth rate of 15%. The town planners are wanting to know what their population is going to be in 5 years. So they're going to use an exponential growth function. F of x is your initial 5,000, 100% plus a 15% growth. In other words, 1.15 to the x power. Oh, but we want for 5 years. So for 5 years, you're going to raise the 1.15 to the 5th power times 5,000. Now, if you have a scientific calculator or your graphing calculator, you're going to enter it in that order. 5,000, parentheses, 1.15, close your parentheses. Remember, this little arrow here is your power button to the 5th power, and it goes ahead and gives you the answer. Now, this is population, this is people, so you don't want to have a fraction of a person. So go ahead and round it to 10,057 people. Now, if you're using a basic calculator or your phone to do these, make sure you always take care of the power first, raise it to the 5th power, and then after you get that answer, multiply it by 5,000. You need to make sure your calculator can do PEMDAS and that it will do the exponents first like the graphing calculators do. Alrighty, example 6. Ignore the bottom 2 lines and just look at the initial value and the decay factor. Notice it's not a decay rate, it's the factor, so you don't need to add or subtract anything. Go ahead and write the function for that problem. Now in this problem, you're wanting to find the average rate of change. Remember, that is just simply slope. Slope is the change in the values, y values over the change in the x values. So we need to first figure out the answer for 1 year and for 5 years. So you want to do 144 multiplied by 0.92 the 1st power, and 144 multiplied by 0.92 to the 5th power. Okay, enter those into the calculator. Let's round to 2 decimal places. And I got 132.48 and 111.42. Now, can you see that this is a decay? It's going down. Okay, decay, let's figure out how much it decayed or how much it changed. Yes, you would subtract. Now, think about it. These are going to be negative because it's a decay. It is going down. It is rate of change. Remember, rate of change is a slope. So you should see a slope that is going down. How much? 21.06. And how long did that take to happen? 4 years. So the time change is 4 years. So the rate of change is that it drops by 5.265 per year. All right, I want you to do the same thing now for the 6 years and the 10th year. Notice in this case, it is also a period of 4 years. Okay, go ahead and pause the video. The next screen you see will have the answer. Okay, did you get it right? Notice it continues to go down. Between these two, it went down 24.77 in those 4 years, or a negative 6.1925 drop. So this one drops roughly 5 per year, and here's 6.6 a year. So the decay is speeding up. Okie dokie, moving on to examples. Oh, first of all, we have to talk about the compound interest formula. Now, compound interest is something that you use a lot with in life. Buying a house, buying a car, credit cards, and most people have no idea how that interest shows up on their statement. They just believe the bank. Here's the formula, and you definitely want to write this down, maybe on an index card or something, so that you have it handy for your homework. Sorry, I'll pause the video and take care of that barking dog. Okay, my silly dog just saw another dog and had to show who was boss. Okay, compound interest is also to your advantage when you are earning compound interest and saving towards retirement or something. A is the amount paid or the amount earned. Okay. P is your principal amount. That's like how much you start with, like your first investment or how much you first buy, like when you buy your house. R is your interest rate. It's the amount that you pay to the bank for letting you borrow the money, or it's the amount that the investment pays you. N is the number of times per year the interest is compounded. Kind of like paid out. So like you could have interest that's just annually, it pays out once, quarterly, in other words, 4 times a year, semi-annually, twice a year, gosh, maybe even like a credit card. They get you monthly. They charge you extra money every month. And then T is the time, and that's in years, that the money is borrowed or that you loan it or that you're leaving it in your investment. And it could be like 6 months, and then you would use a 0.5 because that's a half a year. All right, let's do some of these cool examples. Number 7, you've got $3,000 invested. Okay, that's your principal. The interest is compounded quarterly. That means 4 times a year. So this N is going to be 4. The interest rate is 8%. Interest rate, 8% is 0.08. And the investment is going to be there for 5 years. So the time is 5. All right, now when you enter this in the calculator, it is super important that you understand whether your calculator obeys order of operations or not. Like I said before, the graphing calculators and the scientific calculators do. So I'm going to enter in 3,000, parentheses, 1 plus 0.08 divided by 4. Now, if your calculator does not obey order of operations, you would need to manually do the parentheses part first. And now I'm going to raise it to the 4 times 5 power. I need to go ahead and enter in the 20, because if I don't, it's just going to raise it to the 4 and then multiply everything by 5. All righty. There's the investment. In 5 years, that $3,000 at 8% is worth $4,457.84. Pretty cool. Not sure if you realize this, but if you invest $100 a month, starting when you're 18, by the time you are 40 years old, you will be a millionaire because of this compound interest. Okay, let's look at number 8. Same investment of $3,000. This time, the interest is only compounded annually. In other words, not 4 times a year, but 1 time a year. The same interest rate. Let's see how that affects the problem. So the N down here, this time, annually is 1 time per year. Oh, this is 15 years, not 5. Okay. Go ahead and enter that in the calculator. And I have a wrong answer. I did 300 instead of 3,000. And that would be $9,516.51. $9,516.51. Write that a little clearer for you. Okay, now an interesting thing for you to do would be to go change that to a 5 And just so you can actually get a direct comparison between paying the interest 4 times quarterly or 1 time annually. Matter of fact, I think I'll go ahead and do that. 3,000 and 4,407. So look, you get a bit more money, $50 more in the year. I'll take it. Don't know about you. All right, the last two. You have an initial value of 8,192. Okay, that initial value decreases 25% each day. Think about what your decay factor is going to be. 100% minus 25%, or 1 minus 0.25 to the x power. I need to know what x is if the answer is 1,000. So if this problem were to give me an answer of 1,000, I need to figure out what the x would be. Well, you can go ahead and divide by the 8,192, but then you're going to have a 0.75 to the x power, and we don't really know how to solve that. We haven't learned that. But we do have a very nice calculator here. Okay, so you're going to remember that f of x is just your y. So go to y equals and enter in the equation into your graphing calculator. 8192 parentheses 0.75 to the x power. Okay, now what we want to do is we want to find out when that gives us an answer of 1,000. So when the value is 1,000 for y given the x. And we can do that using the table function. Notice that table is right here and it's in blue. So you're going to touch second and then the graph button. Now, your table might look a little bit different than mine. Let's all get to the same place. You want to go to second and then the table set. Make sure your table, let's start our table on 0, counting by 1, that's our delta, and that these are both automatic. Okay. Once that's done, go ahead and do second table again, and you should see that your table is starting on 0. Now we're going to go down the answers looking for which one is the closest to 1,000. Now if I look at it, when I get to the 7, I have 1,093. 8 is giving me 820. So I know my answer is going to be somewhere in between. So I'm going to have a 7 point something. How can I get a little more accurate? Well, think about what we did yesterday or during the last lesson. Let's quit out of this, second quit, and go to our blank screen. Let's try a 7.5. 8192 and then 0.75, and I'm going to raise it to a 7.5 power. Okay. I think it's going to need to be a little bit closer to 7, so maybe the 7.3 power. And that's pretty close. So I would say that an answer of 7.3 is good for this problem. All right, now I want you to try the same thing for number 10. Set up your equation with your initial value of 7,000, a decay factor, so that's already subtracted, of 0.6 to the x power. Now in this case, you want to find the x that gives you an answer of 25. So enter this into your y equals, and then check your table and see what you can approximate the x for. Go ahead and pause the video while you do that. Did you get an answer? Okay, here is my answer equation. put in 7,000.6 to the x power. I can check my table, my second table set. I am going to start it at 0 again. Now go to the table, second table, and there's a table. Okay. I need the answer, the y column, to be 25. I'm way high right now. I'm going to keep going. 117, 25.396. That's pretty good. And when does that happen? When the x is about 11. Okay, if you're good, go ahead and get started on the assignment. If you're having dimension errors, stay on the video for just one more minute. If you're getting a dimension error, make sure your stat plot is off. Once again, that second stat plot, make sure they're off. If that's still not working, go into Stat and edit your lists and make sure they're all cleared out. Something else you can do is always check your zooms. Go to Zoom, and I would probably do a Zoom standard. That one always seems to work pretty good. Now, this one's having a hard time because remember my graph equation that I just put in was in the 7,000s. If it ever looks like it's locked, you can always hit second and quit. All right, text me any questions you have on calculators or give me a call. My number is posted and I really don't mind talking to you. Have a great afternoon.